Okay, hi, Jadi here, and let's solve one more APK reversing challenge. This one is categorized as a MISC because I believe that the original solution in the mind of the person who created this challenge was not resolved or was not reverse engineering it. But now I'm learning to reverse engineer APKs. So let's go that way. It says the key for getting flag in this game has 3 characters. When you enter 3 character input, it will show the distance to the final answer. If the distance is 0, you found the key. Flag is the MD5 of the key in this format. So, as always, you have an APK, you have to, you don't always have an APK, but just like the cases when you have an APK, you have to download it and run it. It's not advised to run it on your own phone, on everyday phone. It's good to have a test phone or have a better, cheaper solution like a virtual machine. Also, in that case, you will have more control on the whole thing. So let's download it and run it. And the AI app 2, how does it work? It has a input area. It says, okay, try this. This is 69. The hint is numbers or letters. So I can go with, for example, B7B and see how it works. 27. Does the capital letter makes any difference? Yes, 59. So we have to enter 3-letter password till we reach the 0 as the distance. Impossible with the manual labor, but we can do the reverse engineering and find out what the answer is. Bear with me. Okay, so difficult to guess what is happening. Maybe the idea of the person who created the challenge was kind of triangulation and creating some charts and guessing how it works. But now we are learning to do the reverse engineering. Back to the Kali. As I always say, you don't need Kali to be a hacker or cracker or whatever. It just has the tools I need. If I was using a normal Linux like a Debian, Ubuntu, Fedora or whatever, I won't need Kali for these challenges. But on a Mac, I don't want to install APK tool. So this is the package. As I told you, this can be unzipped. It will show you the dex file, but easier for me is to use the APK tool, decompile, more close. Should be closer, not is more close. And open it. So these are the files I have. Smally is the main part of my interest. It contains Smalley code, which is kind of assembly for Java virtual machines. There is one org, Tensorflow. You can see that this is using Tensorflow, which is a machine learning library, and it is using the Tensorflow Lite. Most probably this is only the general Tensorflow Lite library. So I will go back, I will go to the com, Redhorn, AI app 2, same name with the app we had. To check this, I will run my JADX GUI, cancel. We'll drop all these files there to read them and see what this program is doing. Okay. Starts main activity on create. It creates the GUI, then mapped byte buffer. It reads the file which is called model TensorFlow Lite. TensorFlow works based on the models. When it learns something, it saves it in this model file. So we have to work with this one. And this is the whole thing which happens here. Very small. See, it creates an input value. It's a float with 3 values in it. it reads your input string. For example, as we typed AAA, it gets back the character at this and converts it to float. So A will be 64. This is the ASCII. 64 and 64. AAA will be an array with 64, 64, 64, and it will be passed to the most probably new instance and will get an output from the TensorFlow after running it. See, it's here. TensorFlow run with this input value and get the output value, and it will print you the output value as an integer. So the whole thing which happens is it reads something, converts it to the equivalent ASCII value in float, and then uses this model in TensorFlow to give you back the output number. And if it's 0, your input was the correct one. Let's go with it and see what will happen. Okay, these were our files. Practically, we don't need to go further into the files. What we need is that TensorFlow file. And it's in assets. In assets, you have the model TF file. I will copy this somewhere. For example, to the temp directory. It's here. Then I will go to my terminal. We'll create a new terminal. Increase the font size for your eyes. And then let's split the screen as always to make things easier to work with. I will hide here. This is yours, and this is our program. We can start with the IPython. It's always easier to see if we understood the logic correctly. This is my IPython. What I want to do, I will load the TensorFlow file. I will check it with AAA as an input, and I will see if I'm getting 64. So import TensorFlow Lite runtime interpreter as TensorFlow Lite. I have written this program yesterday, so I can just type it. If you see someone just typing all the program and compile it and run it, or interpret it and run it and whatever, it's a little bit fishy. Normally, you do mistakes, you do search, you learn new stuff, so you cannot do it just like a typist. Sometimes when you watch tutorials, the tutor just types and executes. You won't learn much because it will frighten you. Why I cannot just do the same? We always search. Solving this took me more than an hour. Okay, but now I know what I'm doing. Even installing TensorFlow will take some time, but I have it. Anyway, we imported TensorFlow. First, we need to create an interpreter. If you read the TensorFlow Lite, you will see how it works. We say interpreter, model path is model TensorFlow Lite. I'm in the same directory, so this should work. This didn't work because I haven't closed this correctly. Again, it didn't work. TF Lite. I'm in the wrong place. I'm in my home. So let's copy from the temp cp temp model to here, to the home. So now I have the model file. This should work now. Okay, I have my interpreter. Then you can look into this TensorFlow model and see how it works. For example, I can say tab will show you all the possibilities to type or run or call or whatever here. So I will say get input details. It will tell you that your input is type float32. Your input is an array of 3. So it should be like this, and its index is 0. So if I want to give it an input, I have to say on array, on index 0, give it 1, 2, 3. And 1, 2, 3 should be float 32. So we will need NumPy to do this conversion. You can do the same with the output. I will say, give me output details. And it will tell you that, okay, for the output, the index will go to the 15, and it is just one number, and it's float 32. So let's try something. Let's try number. Import numpy as np. I will have numpy to do this conversion to float 32, and I will say I allocate tensors. Now you have allocated one tensor with that model, so let's use it. I set tensor. On the index 0, we check this. For the input, you have to use index 0, and this should be the input. I want 64, 64, 64. But if I run this, it will tell me that cannot set tensor. Got value of type int 64 because my computer is a 64 computer. But expected type float 32. Okay. So instead of this, I will tell from numpy float 32 this. I will say from numpy float 32 this. And from numpy float 32 this. Now I have set my tensor. I will invoke the tensor. This is about working with Tensorflow Lite. If you don't know it, you can search the documentation or just watch. And I can say that I get tensor. Yes. Which index? The output was on 15. So it will tell me that if you give this model 64, 64, 64, which is the equivalent of the A in ASCII charts, the answer is 64. So our system is working fine. We have tested this. Let's go and write the program. I can do a small cheating. I'm not cheating, I'm just copy pasting some of the largest ones. Okay, I can say vim crack py. Okay, I can say vim okay, I can say vim and the program name proc.py. Okay, import Tensorflow Lite runtime interpreter as Tensorflow Lite. Import numpy as np. Then I will copy paste the line I've cheated. No, it's not here. Okay, no problem. I will type it. I is Tensorflow Lite. I'm creating an interpreter with the model path is model Tensorflow Lite. I was able to redo what the app does. Now I can brute force it. Okay, just to make sure that my program works, I will go with A, allocate tensors. Then I will go with I set tensor on the 0, the input index, and I want to input this. What? Numpy float 32 64, numpy float 32 64, numpy float 32 64. Using 64, so later I will be able to just check if my program works fine or not. I invoke and get back the answer. Result equals I get tensor on index 15, which we've seen already. Let's and print the result. I'm just checking if my program works fine or not. We will add the brute force later. I will say Python proc.py. Python 3 I should use because I have installed the Tensorflow on Python 3. So with the input of 64, 64, 64, this is the answer. I believe that since this was categorized at MISC, and for 500, which is a lot of points, I think the person who designed it thought that, okay, with this you will reach to this, then you will do triangulation, you will try other things to see how you are approaching the distance, but we reversed it, which is still very fun and more educational than doing that, unless you are a mathematician. Anyway, so I have res, I can say res 0, 0 to get the number itself. And if you remember, our output was float. So we cannot check if the answer is 0. It should be 0 something, something, something. So let's do the brute force. Now, manually, I have told it for calculate for 64, 64, 64. I can circulate all the numbers and see what will happen. So I will say for A in range, I can try all the ASCII here, but this is too much work. I can start from 32, I think it's space, till 1 to 8. Still, it's too much. But these are the range which we have the normal characters. So I will say A is this for A in range 32 to 1 to 8. For C in, I know what I did. A, B, and C. And we can do check for A, check for B, and check for C. And here I can make it a little bit nicer. Instead of typing this, I can say CHR of A, CHR of B, CHR of C, and the rest. So now the answer for this should work. What happened? Why it didn't input this? Oh. I have not saved it correctly. So, for example, it says for this input, this is the distance. Let's go for the characters and see what will happen, but this is very slow. Anyway, it says for this input, this is the instance. Instead of printing everything, which is slow and makes things not visible when you are printing too much, I will say if res is smaller than 1, print the results. Now the problem is I don't know if it's working, if it's not working, where are we, how much should I wait? So it would be nicer if I print A here. Now A is going, and for each A, we are checking all other B's and C's. So first is checking 32, 32, 32, 32, 32, 33, 32, 32, 34, and 32, 32, 1 to 8. Then it goes to 32, 33, 32, 30. Difficult. That's why we give it to the computers to do. Here we have the answer. See, for M1C, the answer of the model is somehow 1. But for N1C, the answer is 0.0. So when you calculate the int, this will show the 0. The problem is this also should work as the answer, because if you give it with the int, this will also return back 0. Anyway, this is our answer. But the question says you have to return back UUTCTF MD5 of this key. So I have to check the MD5 of this. I will copy this and I will say echo that to MD5 sum. But this is not the correct answer because echo always adds a new line to the end of the string. So you need -n to prevent that. This is the answer, and it tells me that you have to give it to us as UUCT, UUTCTF or something, blah blah, this and that. This is the answer. It was very fun. You saw how we're reverse engineering APK, you saw how we are extracting one of the important files, you saw how we brute force, and also how we use TensorFlow Lite and how to win. Hackers call it winning bread. I was Jody. I would be glad if you subscribe and tell your friends if they're interested in this stuff. Viva!